Hey folks, in this video I want to go over the idea of an interface inside of Java. So an interface. Let's just start by looking at the right hand side because that's where my code is. So here we go. Now my interface, right, this is actually one for counter. So counter we did as kind of a standalone class before, but now we're saying what would happen if I represented it as a counter. We already did a standalone counter, but now we're saying what it would look like as an interface as well. So this is what we have here. We have tally, increment, toString, the same things we had in the previous class. What we're missing though is the constructor. So the idea is this. In Java, an interface is basically going to be a list of methods. So I have a list of methods here, and it's like, well, in Java, okay, so I have a couple keywords. First I have a keyword is interface. So interface is basically just this list of methods. The other one we have is something called implements. And so to write in some more code here, I could have something like this. Public counter. Right, this is basically what we had before, implements increment counter. So I could write something like this, and basically it's like I'm extending what I already had from before. So what is the purpose of this? The purpose of this is basically to help with the kind of black boxing of things. So the outside world basically is going to act as if it's just using an increment counter, right? Increment counter is an API. It's an API that will be implemented by our counter class. Now, the world just uses increment counter, right? So if I have different counters, right? If I have different counters basically that implement the same interface, what happens is they become interchangeable behind the scenes. So I have here my counter, it says implements increment counter. Basically that means that my counter class is obligated to have all those methods, right, that this interface defines. And so if I have someplace else in my program, I would have stuff like this. I would have increment, let's say increment, counter, C1, right? I could have that equals, well, it should be new. Yeah, it'll be new. New counter. New counter, something like that. I'm going to fix my writing there just because. So yeah, we have our increment counter, C1 equal new counter. We were allowed to write code like that. And basically, from the point of view of the world, right, C1 is of type increment counter. And so everybody is basically just going to use that interface, right? They're going to use those three things that are there. You don't even have to know about counter, right? Which is really nice, right? That's our kind of decoupling, right, of this black box, right? Later on, I can do stuff like this, right? I could do stuff like C1 equal new other counter, right? Other counter presumably is another class that implements this increment counter interface, and it's fair game to do that exchange because it's like, well, I have two different classes that implement the same interface, right? That means they're both obligated to have those methods that interface defined, and so they're going to be interchangeable, right? So that's kind of we're breaking access, right, to this as a concrete class, right? We don't have to code in terms of a specific counter anymore. We just code in terms of an interface. So in general, people use interfaces basically in Java to decouple elements, right? To decouple parts of the system because like, well, if I write my code, I can basically just rely on this interface, right, which is an API, and then this API, right, will be implemented by some, actual concrete class somewhere else. And that concrete class, right, is an ADT, right? So I have an ADT, right, basically defined in terms of an API as an interface, and then there's some concrete class that implements that interface, and then I rely on that interface, right? And then the ADT is kind of behind it, right? It does the actual functionality, right? It actually provides, the methods and stuff like that to get work done. So typically that's how we implement ADTs inside of Java is via an interface. Well, we have basically, we start right with a class, right, as our basic way to implement an ADT, and then just to get it even to be a more loosely coupled than it already is, we put an interface on top of it. So yeah. So some benefits here, right? These are all very nice things, right? So the first one, right, is basically, we isolate implementation from functionality. All of a sudden, right, it helps us get that black box going, right? So we don't even have the option of looking inside because like, well, there's no code here behind increment counter. It's just the function names, right? So we made all that disappear. You could even, if you want, right, start using this before you've actually implemented it, right? So I can imagine I can write an interface. I can give it to two teams. One, tell them to code against it. Another one, tell them to actually implement the interface. And that's fair to do. Now the team that is asked to use it, right, they're not going to be able to run their code, but they'll still be able to write it and compile it, okay? Because it's like, well, the compiler knows to expect this method, this method, this method, so I can at least write code against it. It's just that I won't be able to run it at the end, right, because it's, I can't link to that code, I can't actually bring it up, right, because it's not available yet. But I can write against it, right? I just won't be able to run it all the way. Still a cool thing to do. We are obviously right now exposing code, right? This is kind of the safest thing we could do. Sometimes you can think about like, well, maybe you were a company, right? And you wrote this really cool, API, and you have this library and stuff like this, and it's like, well, I don't want it to slip out into the wild, competitors get a hold of it, but I still want to sell it. I want people to use it. Well, you could give them an interface, right? Then they can program against it, right? Even though you're the one maybe holding the binary source code, all they know, right, is that interface that you have, right? You're saying, okay, this is what I promised, right? And so this is what you'll get, right? But all you have is the interface to work from. Another side note here, and this is something that we won't need immediately, right? We will probably need at some point, is basically classes can have multiple interfaces. So over here in my example, I have my counter implements a single thing, right? Increment counter. But I could also, and this would be silly, but I could also have it implement stack. So I could actually have an object, right, that is interchangeable for different things. So I can have a class basically implement any number of interfaces. So I can say, oh, a very common thing would be like say, okay, I have a class, which is an ADT. It implements the stack interface, but also implements the iterable interface. So I have not just a stack collection, but I also have a stack collection that I can explore via the iterable interface. So that's a very common thing we do, right? At least in terms of collections, because iterable is a very common thing, is we'll implement those different interfaces to give us basically the ability to be used in different places, right? I can be used where a stack is necessary. I can also be used where an iterable object is necessary, right? So that gives us more interchangeability. So it's a very nice thing. Last thing note here, right, is again, we go back to the term of abstract classes. An abstract class, right, is not the same thing as an interface. For an interface, nothing has implementation, right? There is no code behind any of these three things that are up here, right? They're all just, method signatures, and that is it. An abstract class basically has some things that look like this, right? There are going to have, just the method signature, and there will also be things that do have code behind the scenes, okay? Or code right there in front of you. It's kind of like an incomplete class. So it's still different than interface, right? It's just an incomplete class where some things are not defined while other things actually are defined. All right, so this was just a quick review of interfaces. You should have seen your interfaces in other classes as well. For us, right, we'll use them in terms of giving us a way, right, to implement ADTs. So we'll use them more kind of in future parts of the class. So once we get basically to our searching and graph topics, that's when we'll end up having more of this discussion, because we'll have interfaces that define like a common data structure, and they'll have different algorithms or different data structures right behind the scenes, right, that we can alternate. So we'll be coming back to this later on.